Hello YouTube, this is me again. It's the Monday evening on the last week of term. So I'm back here to do some a video. Tonight we will look at a very useful theorem called the Pythagoras Theorem. This theorem can be used by students in secondary school and JC even. For all streams. That means even if you're an express, normal academic, or normal technical, you'll be able to use this theorem in your maths. Okay. Now, what is the Pythagoras theorem? Many students think that the Pythagoras theorem is just a squared plus b squared plus c squared. Now, it is not just a squared plus b squared plus c equals to c squared. There are a lot of things that we can use Pythagoras theorem for. There are a lot of things that we can unpack in Pythagoras theorem. So hopefully tonight we will be able to see how else we can use Pythagoras theorem for our maths and in our own lives. All right. So now from the beginning, let us look what are the necessary conditions for us to look at the Pythagoras theorem. Now, we all know that the right angle triangle is necessary for a Pythagoras theorem. Now, this is a right angle triangle. How do I know? Because I drew it because I drew it as such. Now, a right angle triangle is a necessary condition. That it means you need to look for a right angle triangle to apply the Pythagoras theorem. You cannot apply the Pythagoras theorem if you can't find a right angle triangle. However, it's not always that the question or your teachers will show you a right angle triangle in the question, or through examples. You need to look for that sneaky little right angle triangle in your questions. So for example, on the shapes on your right, over here you can see a few shapes. Okay, this is an equilateral triangle, not really a right angle. Okay, but can you notice that there's actually a right angle hiding over here? If I can draw, yep, I can draw this. Okay, if you can see this, there's actually two right angle triangles actually hiding inside this equilateral triangle. So if you can draw this line down, you can see that there is indeed a right angle triangle over here. Now, how about for this rectangle? Now, if you see, we can draw a diagonal line across the rectangle. Okay, that cuts the rectangle into two equal halves. And if you can label your rectangle A, okay, B, C, and D, you see that triangle ABD is a right angle, where the angle DAB is a right angle, and angle BCD is a right angle triangle with angle BCD as a right angle. Okay, so you can see that there are right angle triangles hiding in two shapes. And also there are right angle triangles hiding inside the circle. So for example, if you have the center of the circle here as such, okay, and you draw your diameter as such, okay, if you draw your diameters as such, okay, you notice that if you join the edges together this way, you will form a right angle triangle inside the circle as well. Okay, so why does this matter for a Pythagoras theorem? Looking at these shapes, we can see that Pythagoras theorems can be used in so many instances. For example, trigonometry, circle properties, geometrical properties, and so on and so forth. So that's why understanding Pythagoras theorem is so important, and it becomes so useful as we go along. Okay, now the next thing we need to know is the hypotenuse, or hypotenuse, or hypo, as what the students say. Okay, so where is the hypotenuse? Now, teachers usually define the hypotenuse as the longest side of the triangle. Now, this is insufficient because although the hypotenuse is the opposite side of the right angle, and it is the longest side of the triangle. So what do I mean that is the opposite side? If the right angle is here, okay, I just name it theta, and you assume that theta is an eye, okay, as in a 眼睛, is your eyes, what you used to see. Okay, you look across the triangle, okay, and you identify the side which is opposite the 90 degrees, and this is where you label it the hypotenuse. Okay, and how about these two other sides? Now, these are the two other sides of the triangle. Some may say that this is the base and this is the height. Now, it doesn't matter as much over here, because the main thing that we are looking for out here in the Pythagoras theorem is the hypotenuse and the two other sides. Now, this is just what it means when you say a squared plus b squared equals to c squared. Now, this is a YouTube video that we found, and this is what it means over here. Okay, if I'm going to turn off the sound, okay, if you take a look, the hypotenuse is over this side, all right, and the two sides are over here. You notice that this square is a square because this length over here is the same length as this side of the triangle, and similarly, this side of the triangle is this length. This means that these two areas are squares. Okay, and you see, if you can see the waters in these two squares, as she flips the toy around, the water fills the third side completely. This means if you see that a square is a square plus b square, all right, will give you the same area as the hypotenuse, the square formed by the hypotenuse. All right, and now we flip it back around, we see that the water that is taken, the square formed by the hypotenuse, will fill up the squares of both sides, the sum of the squares of both sides. Okay, so if you wish to look at this video another time, you can, there's a link over here. I will probably put the link in the comments, or the link as a pop-up box if I manage to. Now, alright, so as we can see, as I said just now, this is the hypotenuse, the longest side of the triangle. Opposite the right angle is the hypotenuse. Okay, usually we label this as c squared. That's where you get a squared plus b squared. A squared over here, and the other side b squared. Okay, and therefore we always say that the hypotenuse, the Pythagoras theorem relationship is a squared plus b squared equals to c squared. Okay, so that's how you get the relationship of the Pythagoras theorem. That's just an example how we get c squared, the hypotenuse, the length of the hypotenuse, using numbers. For example, if let's say we assume b equals to 3 and a equals to 4, that means the base of the triangle is the base of the triangle is 3, and the height of the triangle is 4 cm. How do we find the hypotenuse? Okay, so a squared, we just sub in 4 squared plus 3 squared, okay, equals to c squared. 4 squared is 16, 3 squared is 9, okay, and this will be 25 on the left hand side. Now, always remember that this is a c squared, you will need to square root this, so square root of 25 equals to c, squaring both sides, by square rooting both sides, and you get c equals to 5. Then that's how we do it. Now, so you have found the basic use of the Pythagoras theorem. Now, it is also possible that the question gives you the hypotenuse, for example 13 cm, and it gives you one of two other sides, okay, for example 12 cm. Okay, so they will ask you to find this side, x. What is x? So let's go back to our relationship where we know a squared plus b squared equals to c squared. So if we can label our sides, this is the hypotenuse, so we label this as c, this as b, as always, as before, and this is a. Okay, so a squared plus x squared equals to 13 squared. Okay, now you notice that x squared is the subject of interest, which means that we need to make x squared a subject. So we deduct 12 squared from both sides. Okay, I'm struggling not to use the word bring over because that's not mathematical. Okay, so 13 squared, using mental sums, if I'm not wrong, is 169. And 12 squared is 144. Okay, using mental sums again and the abacus class that my parents sent me to when I was younger. And this is 25. X squared is 25. Okay, so remember this is still x squared, this is not x. You need to square it both sides. Okay, and we square it both sides. And we get x equals to 5 cm. Now, that's how we do the Pythagoras theorem. Simple, straightforward. It doesn't matter which side you are given. You need to have at least two sides to use the Pythagoras theorems. Alright, just so let's recap what you need. The first condition that you need a right angle triangle. Okay, and after getting the right angle triangle, we look for the hypotenuse. We need to identify the hypotenuse first, because that would inform us where can we substitute the number and where our terms will go. And after that, we need to have at least we need to be given two sides at least to use the Pythagoras theorem. So that is all for tonight. A very short video on the Pythagoras theorem. I hope this is useful. Once again, I appreciate comments and questions. The email address to send the questions and the comments are in the link. Do help me help my students, and do help me help you if you think that it's good. Thank you very much, YouTube, and I hope to see you all very soon. Good night.